All right, this is part B of the exponent video. So we are still on the set of notes for 13.2, 13.5. We are on number 21 now. So here, refer back to the previous page here. The next rule that we're going to learn about is rule number 2, which you might see described as the quotient rule for exponents. So basically, with rule number 1, we had, two things the same base, that if you're multiplying, you can simplify that by adding the exponents. Well, if you're dividing, you can simplify that by subtracting the exponents, all right? So a fraction goes with subtraction, okay? All right, so that's the rule we're going to be using on this next bunch of problems here. So number 21, we have x to the power of 13 over x to the power of 3. So we're just going to subtract the exponents. All right, so the base stays the same, and the exponent is going to be 13 minus 3, and we know that 13 minus 3 is 10. Whoops. So your final answer is x to the power of 10. Okay, and then number 23, all right, we have b to the power of 20 over b to the power of 23. So 20 minus 23 is equal to negative 3. All right, now we want to get rid of the negative in the exponent, so that turns into 1 over b to the third power. All right, now if you look at the examples on the homework, they explain this a little bit differently. So what they would say, and maybe it's a little bit easier, I don't know, but what they're going to try to explain to you there is that if you've got the larger exponent on the denominator, then ultimately your whole thing here is going to end up on the denominator. And then you've got nothing else on top other than you just put a 1 up there. So, they would say, okay, well, 23 is bigger than 20, so my b is ultimately going to end up on the denominator, and then 23 minus 20 is 3. So if you look at the explanation on your online homework, that's probably what they're trying to explain to you on that. All right. So number 22, we have b to the power of 16 over 5b to the power of 13. So 16 minus 13 is 3. So it's going to be b to the third power. And then the 5 is just going to stay there on the denominator. Okay? Okay. Number 24 has 2 different bases, so therefore it can't be simplified using any of these rules. So that's as good as it gets there. All right, number 25, we have 8 to the power of 9 over 8 to the power of 12. Okay, so 12 is bigger than 9, so it's basically going to be 1 over, and then 12 minus 9 is 3, so that's 1 over 8 to the third power. And in this case, they're probably going to want us to go ahead and evaluate that. So 8 times 8 would be 64, and then 64 times 8 is 512. So 1 over 512 is the answer. On number 26, there's, as there always is, multiple ways you could go about this. Since both of my exponents are negative, I would probably just go ahead and flip it, and that'll get rid of the negatives. So that would make it p squared over p to the 5th power. All right, and now 5 is bigger than 2, so my p is going to be on the bottom. 5 minus 2 is 3, and then you just have a 1 on the top. So 1 over p cubed is the answer. Okay, and the next several problems are all using rule number 4, which we touched on a little bit. 4 and 6, kind of the same thing. This one's multiplying, this one's dividing, but it's just a matter of distributing the exponent. Okay. So number 27. Oh, actually, I guess that's what I should have said is that rule number 3. Yeah, so when you have an exponent raised to another exponent, you multiply the exponents. That's what we're doing here. And then we're going to combine that with also distributing the exponent as well. So w to the power of 5 to the power of 8. So 5 times 8 is 40. Okay, and then number 28. So we're going to distribute that exponent. So that's going to be a squared. And then with the b, you're going to multiply 4 times 2, which is 8. So it's b to the 8. Number 29. 5 times 3 is 15. 5 times 2 is 10. Okay. Number 30. 2. So let's go 2 squared. So one mistake a lot of people make is they will focus on the variables and the exponents. They forget about the coefficient. So don't forget, we do need to do 2 squared. So 2 squared is 4. Okay, so we did that. And then 2 times 4 is 8. So that'll be x to the 8. And then that'll just be y squared. And then 2 times 3 is 6. So z to the power of 6. Okay, number 31. So negative 2 to the power of 4. So that is a negative number raised to an even exponent. 4 is an even number. All right, so I'll go ahead and just write negative 2 to the power of 4. And then 5 times 4 is 20. It's going to be 8 to the 20. So that's going to be, so 2 times 2 is 4, times 2 is 8, times 2 is 16. Okay, and it's going to be positive 16. All right, so positive 16, a to the 20. All right, number 32. So that's going to be p to the power of 25 over 6 to the power of 5, x to the power of 5. Okay, and I'm going to go ahead and just multiply out 6 to the power of 5. Three, 4, 5. All right, so that's going to be 36 times 6. Okay. So that's 216 times another 6. So that's 1296 times one more 6. All right, so I got p to the power of 25 over 7,776 x to the 5th. righty. Number 33. So I have 6 to the power of 4. And then 3 times 4 is 12. So that'll be y to the power of 12 over 6 squared y squared. So I could multiply out 6 to the 4th and then multiply out 6 squared and then divide them. But let's make it a lot easier. Okay, so 4 minus 2 is 2. So that would be 6 squared. And then 12 minus 2 is 10. So that would be y to the 10. Now I know that 6 squared is 36. So 36 y to the 10 is my answer. All right, next page. All right, here we have a bunch of fractions to basically reduce. So 15 goes into 45 3 times. All right, then let's see, a to the 4th and a to the 4th, we can just totally cancel that out. Then 3 minus 2 would just be 1, and if it's an exponent of 1, you really don't even need to write it, so just carry over the b, and that is our final answer, 3b. All right, number 35. So we've got a negative, that's just going to stay there. You can put it out in front of the whole fraction, or you can put it in front of the numerator. Either one of those is perfectly fine. Okay, let's see. So, yes, and this answer still is going to be a fraction ultimately, because I know that 36 goes into 72 2 times. All right, now with my x's, 5 is bigger than 3, so my x is ultimately going to be on the denominator, and 5 minus 3 is 2. All right, and then for the y's, there's like an invisible 1 exponent on this y right there. 7's bigger than 1, so my y is going to be on the numerator, and 7 minus 1 is 6, so it's going to be y to the 6. All right, so that's my final answer, negative y to the 6 over 2x squared. Okay, number 36. So we never really like to have decimals inside of our fractions, but I know that 31 would go into 62 exactly 2 times. So 3.1 would go into 62 20 times. Basically just move the decimal point. All right, so 31 goes into 62 20 times. All right, then for the letter S, 8 is bigger than 5. 8 minus 5 is 3, so on the denominator, that's going to be s to the 3rd power. Then I've got an invisible power of 1 on that t right there. So 3 is bigger than 1, so t is going to be in the numerator. And 3 minus 1 is 2, so it's t squared. So my final answer is t squared over 20s to the 3rd. Okay. All right, number 37. So 3 squared is 9, and 3 to the power of 0 is 1. So I really don't even need to write a 1 there. All right, 5 is bigger than 3. 5 minus 3 is 2, so I've got x squared on my denominator. And then 7's bigger than 2, and 7 minus 2 is 5. So I'm going to have y to the 5th on the numerator. So my final answer is 9y to the 5th over x squared. All right, number 38. So I have a whole thing in parentheses raised to a negative exponent. So the first thing I want to do is basically put a 1 over the whole thing, and then the 3 will be, the negative 3 will change to a positive 3, and then everything in the parentheses will just stay exactly the same. Okay? And then I can go ahead and distribute that power of 3. So 4 to the 3rd power. So 4 times 4 is 16, and then 16 times 4 is 64. We just did that in part 1 or part A of this video. So that's going to be 64. And then 3 times 2 is 6, so it's x to the 6. And 3 times 4 is 12, so it's y to the 12. Alrighty. Alright, number 39. So I just need to take the variables that have negative exponents and just move those down. So the 4 is going to stay there. And y to the 4 is going to stay there. And I'm going to move this down. It's going to make it x squared, and I'm going to move this down. I'm just going to make it y cubed. All right, so when you've got all these things next to each other like this, they are multiplying. So you're technically multiplying y cubed times y to the 4th, and you can simplify that by adding the exponents. 3 plus 4 is 7. So it'll be x squared y to the 7 on bottom. So 4 over x squared y to the 7. That's our final answer. Okay. Number 40. All right, so we've got something in parentheses raised to a negative exponent over something else in parentheses raised to a negative exponent. So we could go ahead and flip that, and that would get rid of those negatives. So that would make it 2ab squared in parentheses raised to a positive 4 over 2ab squared in parentheses raised to a positive 3. All right, now normally I would go ahead and distribute those exponents. However, in this case, we can just make it a lot easier on ourselves because it's like all of this in these parentheses is identical to all the stuff in those parentheses. So it's like having the same base here and here. So I would just subtract those exponents. 4 minus 3 is 1. So that would give me parentheses 2ab squared to the power of 1. So in other words, it's just 2ab squared is the final answer. All right, so number 41, I just need to take the variables that have negative exponents and move them to the denominator. So z to the 3rd power will be the numerator. And then on the denominator, I'm going to have x to the 5th y squared. All right, and that's all for that problem. All right, number 42, I have a fraction in parentheses and it's raised to a negative exponent. So the first thing I would like to do is basically just flip the whole fraction, and then that negative exponent will turn positive. All right, so in parentheses, we're going to have c squared over 2a cubed b to the 0, and all of that will be raised to a power of positive 3. Okay, now we can distribute the exponent. So 2 times 3 is 6, so that's going to be c to the 6 on top. And then, like I said, don't forget that we have to do 2 to the power of 3. So 2 times 2 times 2 is 8. And then 3 times 3 is 9, so it'll be a to the 9. All right, now b to the 0 equals 1. So where it's like saying you're multiplying or dividing by 1, it doesn't really do anything. So we can just cross it out. And this will be our final answer. All right, number 43. So there are multiple ways to go about this, but I think what I'll do is I'll go ahead and just subtract the exponents on the a's and subtract the exponents on the b's. So for the a, we're going to have -6 minus -2. For the b, we'll have the exponent will be 3 minus -5. All right, now minus a negative turns into a plus. All right, so -6 plus 2 equals -4, and 3 plus 5 equals +8. All right, so we still have a negative exponent. So we want to take the variable that has the negative exponent and move that to the denominator, which will get rid of the negative. And then b to the 8 will be the numerator. All right, and that is the end. I keep meaning to delete this last page. I don't know if you found this last page on your notes about scientific notation, but we do not need to know that for this class, so we can just throw that one away. All right, so that's the end of 13.2 and 13.5 about exponents.